Hi, in this video we are going to see an application of the convolution property of the Fourier transform. So let us start with two signals. x1 of t is equal to e to minus alpha t u of t, and x2 of t is e to minus beta t u of t. Alpha is a positive constant, and also beta is a positive real valued constant, and alpha is not equal to beta. So we have these two signals, x1 of t and x2 of t. They are both exponentially decaying signals. For positive values of t, for negative values of t, the signals are 0. So we know that the Fourier transform of x1 of omega is 1 over j omega plus alpha, and the Fourier transform of x2 of t is x2 of omega equal to 1 over j omega plus beta. So the Fourier transform of the convolution of x1 of t with x2 of t will be equal to the product of the Fourier transform. So we will have 1 over j omega plus alpha times 1 over j omega plus beta. Okay. So by using the fact that the Fourier transform of the convolution of two signals will be the product of the Fourier transforms, we are able to obtain the result immediately for the convolution of x1 and x2. Now let us do the following. Let us calculate the convolution and in time domain, that means, and then calculate the Fourier transform of that signal. So let x of t be the convolution of x1 of t with x2 of t. Okay, we have the convolution operation in time domain. So what is x of t? X of t can be expressed as the integral from minus infinity to plus infinity, x1 of tau, x2 of t minus tau. So we can write this in terms of the expressions, explicit expressions given for the signals from minus infinity to plus infinity, e to minus alpha tau u of tau, e to minus beta t minus tau u of t minus tau integrated with respect to tau. Okay. Now let us look at the signals u of tau and u of t minus tau. Now for t less than 0, if we choose t as a negative value, for that t, x of t will be equal to what? Let us try to calculate that. Now for t less than 0, let us plot u of tau and u of t minus tau. So u of tau will be this graph. For tau greater than 0, u of tau is 1, and otherwise for tau less than 0, it will be 0. Then u of minus tau will be just the mirror image with respect to the vertical axis. So it will be equal to 1 for negative values of tau and 0 for positive values of tau. And when t is less than 0, this u of minus tau will be shifted to t, or the 0 point will be shifted to t. So for t less than 0, okay, let me plot it here. This is tau, and this is u of t minus tau. Okay, maybe I should show this by dotted line. So this value is 1, and this point is t. So this is u of t minus tau. So what can we say about the product u of tau and u of t minus tau? So u of tau and u of t minus tau do not overlap. Okay? So the integrand will be equal to 0, because u of tau and u of t minus tau will not overlap. Their product will be equal to 0, and therefore x of t will be equal to 0. So for negative values of t, the convolution integral turns out to be 0. Next, we can just look at the case t greater than 0. What happens when t is greater than 0? So let us look at that case next. Okay, for t greater than 0, now u of tau and u of t minus tau will overlap, because this is u of tau equal to 1 for positive values of tau, and u of t minus tau will be, first we have the reflection operation, u of minus tau, and then shifted by t. So it will be this graph, u of t minus tau, for t greater than 0. Therefore, their product will be equal to 1 for t between 0 and t. So if we plot the product as a function of tau, u of t minus tau, so it will be equal to 1 from 0 to t and 0 elsewhere. So the convolution integral x of t, okay, let us write it in full form once more, from minus infinity to plus infinity, e to minus alpha tau u of tau, e to minus beta t minus tau u of t minus tau, integrated with respect to tau. So u of tau is equal to 0 for negative values of tau. So this is 0 for tau less than 0. Therefore, we can replace the lower limit here by 0. And if you look at this function, u of t minus tau, this is 0 for tau greater than t. Because if tau is greater than t, here we are assuming that t is fixed and tau is the variable because it's the variable in the integration. For tau greater than t, t minus tau becomes negative, and therefore u of something negative is equal to 0. So this means that by means of this observation, we are able to replace the upper limit by t. So the convolution integral becomes from 0 to t. Now, in this range, as you see from the previous graphical observation, the product is equal to 1. So we have e to minus alpha tau, e to minus beta t minus tau integrated with respect to tau. Okay, so let us continue here. Now, e to minus beta t is not a function of tau, therefore it can be taken outside the integral. From 0 to t, e to beta minus alpha tau integrated with respect to tau. Okay? So we have e to minus beta t. Okay, the integral here is 1 over beta minus alpha e to beta minus alpha tau evaluated at 0 and t. So 1 over beta minus alpha can be taken as the multiplier. E to minus beta t, then we have e to beta minus alpha t minus 1. So this can be written as 1 over beta minus alpha e to minus beta t and e to beta t will make 1, the product. So we have e to minus alpha t and then minus e to minus beta t. Okay, so this is the value of the convolution integral for t greater than 0. Therefore, x of t, which is the convolution of x1 of t and x2 of t, can be written as 1 over beta minus alpha e to minus alpha t minus e to minus beta t multiplied by u of t. So the general expression must be equal to this because we have obtained that for negative values of t, the convolution turns out to be 0, but for positive values of t, we have this result as the result of the convolution operation. So, Fourier transform of x of t, shown by x of omega, can be obtained as follows: 1 over beta minus alpha 1 over j omega plus alpha minus 1 over j omega plus beta so this turns out to be 1 over beta minus alpha. Now j omega plus beta minus j omega minus alpha divided by j omega plus alpha times j omega plus beta. Now j omega terms will cancel out and we have beta minus alpha in the numerator and also beta minus alpha in the denominator, and again as expected we obtain the same result, which is just the product of the Fourier transforms of x1 of t and x2 of t. Okay. So by calculating the Fourier transform of the convolution of x1 of t and x2 of t, we get the same result as expected. So thanks for watching.